On the next Built to Last, we take a bird's eye view of a construction project in Chicago, from the outside in and the inside out. It's a commercial project using the latest techniques for interiors and much more. Next on Built to Last. Hi, I'm Bruce Obora. Before the creature comforts get installed in your home or in commercial buildings, the material and finishes play a big part in soundproofing, ambiance, and the overall maintenance. Today I've been invited to a construction project in Chicago for a first-hand look at how everything gets put together. Let's check it out.
Everything started here back in September. We actually came up here. This was an existing roof, and it was approximately 5 foot down from here, this elevation that we're standing at. A ballasted roofing system was in place. We removed all that, peeled back the roof, put down a traffic membrane underneath it, and the first order of business was erecting the trusses that relocated the columns for the building.
Okay, so originally, this was a 5-story building, so everything from here is new construction. And I see off to the side here, this is pretty much was roof level. You're protecting the existing structure here that's in place.
Well, this is the atrium that goes through the entire mall itself. So underneath us is an active mall. Stores and everything don't even know that we're up here building a building currently. And that level of protection that we've put in place is if anything falls off the structure during construction, it's all been designed to withstand any loads that would come down off of the building.
Okay, and I see you guys are pretty far advanced here.
Oh yeah, we've been moving up pretty well. Typically, everything's on a 5-day cycle. The windows, the interiors, everything moves at a 5-day cycle through the building.
So Jeff, we're here up on the 23rd floor. Kind of what's taking place here?
Well, we're actually in a transition phase, you would call it. We've already removed the reshores from the building, and we're going into, the carpenters have been up here, laid out the floor, snapped all the control lines for the interior walls and the MEP finishes to start. But the first thing we got to do is get the building enclosed. So the next phase of this is going to be putting in the exterior envelope. Once the envelope's on, we'll go ahead and start the interiors and MEPs.
Okay, and this is pretty much typical as all the floors go up, correct?
Everyone goes through it. These are what they call receptors. There's 3 crews that work on this for the building enclosure. So you have your layout crew, then you have your receptor crew, and then you have your physical window installations. This is the first part of the whole step. Layout's already done. They put in the receptors, and as we work ourselves down here, you'll see the windows starting to get put into place and the heads and sills being caulked.
So Jeff, we got a lot going on up here on the deck today. Kind of what's taking place here?
Well, we've kind of gone from a mildly reshored floor to full action, the beehive, I guess you would call it, you walked into.
Sure.
We're in the process of prepping and getting ready for the concrete deck pour. So everything that's going in the deck is the reinforcing, the mechanical systems that are ran into the deck, so a lot of the electricals embedded into it. These are the conduits that are embedded into the deck. One of the things, we have a new product that we're working out here called Stubbies, or Conduit Stub Up Eliminator. This is something new on this project. It's able to, instead of having the conduit project through the top of the concrete, it allows it to actually keep the coupling embedded into the concrete. So after the pour, that's stripped out and there's no longer a stub up sticking up, and eliminates any trip hazards that we have on the floor.
At what point are you ready before the pour? You said this is roughly a 2-day process here?
A lot of times what will happen, we've got this thing dialed in so well on this project that around 4:30 tonight, all activities will cease and desist.
Really?
Tomorrow morning we'll be up here and actually pouring already. A lot of times the roughing's actually taking place as we're coming across with the, so if we're starting the concrete pour over here on the east side, working to the west, the guys will still be roughing in over here. We've got this thing dialed in so well that we're actually able to get it in the night before and just pour the concrete by 11 o'clock. The next morning we're poured out, we're recouping materials, bringing it up, going up to the next level and making our column pours that night.
Wow, it looks pretty great. It's amazing to see everything taking place at this rate.
Yeah, there's no time to wait. We got a pretty heavy schedule on top of us. The nice thing is we're actually up here pouring concrete and building floors out below. And maybe we can take a look down there and I can show you where we're building out. Literally on level 7, we're already to the point of getting ready for punch list.
That's great, let's take a look.
All right.
So Jeff, what do we have going on here?
Well, Bruce, this is typical in residential construction. There's no drop ceiling, so we actually use the concrete ceiling as the finished product in the unit. They start out by boxing the joints, as you can see up here, and that's where the formwork embedded a deeper pocket into the concrete. So they skim that, and then they come along with a cover coat process and spray it with a gypsum product, and that goes on in 3 layers to the point where this will almost look like glass and a perfect finish on the ceiling.
Okay, now that's something that takes place before you start doing any of the framing?
Exactly. So the first thing we would do is come up here and do the layout, so the guys will actually know where there's finished ceiling and not finished ceiling. Once the layout's done, this crew will come up here, they'll actually box out the joints and then come through and cover coat it and finish it.
Okay, great. So the next step would be the framing. Can we take a look at the framing?
We'll head on right down. All right, Bruce, as you can see, we're progressing as we go down through the building. As you saw above, we had the finished ceilings going in. Here, ceilings have been skim coated. The framing's in, and the mechanical systems are beginning to be roughed into the walls. It's a process that's typically done. Each turn on the floor is approximately 5 days. So okay. Skim coating's 5 days, framing's 5 days, mechanical rough's 5 days. And the next phase will start coming up here once we complete with all the roughing in the walls. The city inspectors will come through here, give us the approval, and then we'll come up and start drywalling the next units.
Okay.
This is a perfect example of a 2-bedroom unit, 2-bedroom, 2-bath. Framing is in for the kitchen. This would be the kitchen area in here, little island over here, bedrooms and bathrooms. And you can't complain about the view, that's for sure.
No, and I noticed everything's metal stud framing, you roughed them for sprinklers, so everything's pretty much non-combustible.
Totally. It's part of the code that we have to follow. So what they call fire loading the building, and as we go down to the lower floors in the progression of this, you'll start seeing cabinets and flooring going in, which are the combustibles they're concerned about.
Okay, and that's something we could take a look at now?
Sure, we'll head down there. Well, Bruce, you can see we've made a little bit of progression from up top.
Sure.
We're actually in the state, we've rocked the walls, all the MEPs are embedded, and we're final taped, and going into this project has 2 coats of paint, so we're coming in with the prime coat at this time. You see that we have some of the cabinets that have already been delivered to the floor, so once the painting's complete, we'll bring the flooring guy in. Flooring will go down, we'll start bringing cabinets in and going into finishes with tile and flooring.
Okay, so that's the next step of the process here then?
Exactly.
Okay, great. Do you have a floor that's pretty much complete?
We sure do. We actually have a mock-up completed we can go down to. Well, Bruce, here's the what I would call the ta-da moment, the finished space. This is what we use as our mock-up. Mock-ups are actually completed way ahead of schedule for the build-out cycle in order for us to go through every detail on the project, including tile layouts, as you see behind you,
Sure.
cabinets, where the pulls on the cabinets actually go, things of that nature, receptacle locations, everything. Everybody comes through here, gives it a final approval, says this is exactly how we want it. If they don't, we make the adjustments here, and then we go build it 690 more times.
And you have the appliances, everything's pretty much in place except for working condition.
Yep, we could actually cook up a dinner if we wanted to.
Okay, now I notice off to the side here, you monitor the space as well?
Yeah, it's in our best interest to make sure that that's a humidistat that we have back there. Our guys come through here on a daily basis and make sure that we track the humidity levels. A lot of the materials that are being used in this space are affected by humidity, so if we get too high of levels, we make sure that we adjust it and we are under temperature control.
Okay, because we really, for time on now, you're still under construction.
And I'm still under warranty, so I got to make sure that I provide a finished product that hasn't been affected by any moisture content.
Well, I really appreciate it. It's great to see this really from, ground up to get to this point, so I really appreciate your time today.
Anytime. I appreciate you coming out.
Ulick, I appreciate you having us on site here today. Looks like there's a lot going on.
Yeah, you're welcome, Bruce. Yeah, we've got approximately a 10,000 square foot addition onto an existing building. Our scope of work for this job includes the light gauge metal roof trusses, sheeting the roof. We have all of the interior framing, which is also metal framing inside here. We've got a fair bit of work in progress right now.
Okay. I see they've got some metal stud framing and things taking place inside. Are those things that we can kind of take a look at the progress?
Sure, yeah. We'd be more than happy to have you come on inside and take a look. Okay, this is Matt and Bill. These are our crew here for doing this interior build-out work. They've been inside here for the last couple days. We've taken the blueprint, we've laid out all of our walls, we've transferred our wall lines up to the ceiling here, lasered them up, we've installed our top track, we've come back through bottom track, we've started laying out our door openings, window openings. A lot of what we're building down here, there's classrooms, there's some office space, there's some common area. So these guys, as you can see, they've got the majority of their layout done. We've come through with more or less the generic framing. We stuffed our studs, openings, framed them in, and now that we have the majority of that work done, we're going to focus in on some of the more detailed areas of the build-out. We've got some radius walls that we're building here. Billy will talk us through the process of how we're going to put this thing together.
So with a radius wall, it's a little more complicated than just a standard wall. They've come out with this stuff. It's called flexibility track. It's a lot easier to work with than cutting up regular track. This actually bends, and then it's got little tabs right here that you can actually hammer down, and it locks it in place. So you have your radius established, and then you beat it together on the floor. And then all you have to do is shoot up a couple points on the floor after you strike a radius, and then just attach your top track to the top of the structure.
Okay, so to get to the point of laying out the radius, is that something that's specified on the print, and how do you pick your points?
Yeah, all of our dimensions come from the print. Most of them are from center of wall. So when you're laying out a radius, you kind of got to do some research, and you find the center of your radius, and then they give you a point at which they want the arc to be. So you just find your rear point and then hold your tape there and strike your radius on the floor.
Okay, so once you get that on the floor, how do you transfer that up towards the ceiling?
Well, you need a point laser. It just shoots one single dot up to the ceiling. And you've got to get a point like every, say, foot.
Oh, okay.
And it takes time. You go 1 point at a time to make sure it's all plumb and accurate.
Okay, so that way, that kind of assures everything will match smooth along the way.
Yeah, lasers have come a long way, and they help us out a lot.
Okay, great. Is this something you're set to do now?
Yep. So we've got our radius here laid out, and now how we transfer the marks from the floor up to the deck is we use this, it's called a point laser. When you turn it on, there's a line that shoots straight down. You can see on the floor there.
Okay.
And that line transfers straight up. So we put that right on our mark on the floor, and that's how we know we're perfectly plumb right on the ceiling.
Okay. Now you're dealing with a couple different conditions here. You've got the beam and the deck, two different heights.
Which isn't ideal, but we've got some lookouts coming down from the concrete deck to match the same height as the steel elevation. So that way when we put the track up there, it's all going to be at the same height.
Okay.
But we could also still run our drywall all the way to the ceiling so we still keep our fire rating.
Okay, we'll let you keep going.
So now we've got our track all set and all the tabs are beaten down, so we're ready to set it up into place now.
Now I noticed on this job everything's pretty much stud framing. I assume there's a reason for that.
Yeah, we have life safety issues with this type of a project. The metal framing, meets and or exceeds any of the UL ratings that we have to achieve for this type of a project. We have to make sure our head of wall details, fire safing, smoke is a big issue in a building like this. So.
Okay, and I noticed too, it lends itself to a little bit more friendly for the other trades and stuff coming in place.
Yeah, for sure. I mean, your metal stud is obviously a lot straighter than a standard wood stud. It works well for this type of application. There are punch outs in the studs that help the electrician and some of the other trades work around those areas, and pretty much it's the product to use for a build out of this type.
Everything pretty much has its application.
Yeah, absolutely.
Well, I appreciate taking the time. Everything looks great here. Thank you.
Yeah, listen, you're more than welcome. Thanks for coming out.
At the Carpenter's Apprentice and Training Center, the art of lathing continues to be the craft of a skilled carpenter. Like many modern construction techniques, continuing education and hands-on training provides an important opportunity to work with the latest materials.
Lathing was involved in residential construction. They installed these wood strips with a 1/4-inch gap, which was called wood lath. And as it progressed in time, then it came into 1.5-inch iron, 3/4 iron, and then metal lath.
An early practice in construction was the use of wood lath and plaster. Lath and plaster was used in residential housing to build walls and create architectural shapes.
Now we use innovative products that are from Armstrong that accepts metal lath, and it's used for plaster.
Innovation is very important to remain competitive. Things are changing very fast. We take new product development very seriously, and we have installation support reps located around the country that are on jobs every day and working with the contractors and helping identify the needs for the industry.
While drywall is a common method for the construction of interior walls, new metal lath with plaster has become a construction option for commercial buildings, especially useful considering the versatility they offer for the framing of architectural shapes.
One thing that's good about these products is, with lath, we could use anything that an architect creates. With domes, with groin vaults, with segmental barrels, serpentine ceilings, we still need to use these products in order to create with metal lath. We could use drywall, but it's hard to conform drywall to these shapes. So lathing's been in this industry to make an architectural dream exist.
The flexibility of the materials allows for time-saving installation without any sacrifice in strength and durability, a drawback of traditional wood lath.
For the lath and plaster system, you're going to use our 3-foot tees or 2-foot tees. A key part of some of the innovation and engineering in this system is, our peak form, which you can see it adds strength to the product and makes it easier to cut. So here's our faceted main, which the knockouts come out of the box with this little piece of metal here to keep it straight during shipping. Then you would cut it and now the main beam becomes totally flexible to put in your template.
So when we look at this material, it's obviously it's steel, it's a lighter gauge. Is this recycled material? I mean, sustainability
Absolutely.
becomes a big issue.
Absolutely, and I mean, steel is the most recycled material in the world, and it's 100% recyclable. So we recycle everything, and many of our products are available in high recycled content.
Oh wow, that's great. So even the cutoffs and things, scrap in the field, all
Yeah,
that can be
yeah.
recycled too then?
Even at our plant, all these little knockouts, all that steel goes in a conveyor belt under the floor and gets recycled.
Training obviously becomes an important factor here too, because obviously this is a new product to the system, a little different from what people are traditionally used to working with.
Yeah, no, absolutely. Training is huge, because to ensure a safe and quality install, training is crucial, that the members and the installers know how to work with the new product.
Here, the construction of a growing vaulted ceiling is just one example of the marriage between new materials, techniques, and a craft that is being continually refined for the modern lather.
In the past, we would have to form it all by hand. So if we had this exact shape, and depending on how many pieces we needed to be framed, we would have 3/4 iron. We'd have this layout on a template or on the ground and shape it by hand, forming it with our eye, and then matching it close to the template until we got it to precise measurement. This is probably cutting our time by half, which the industry likes, because now we are able to build more jobs with metal lath.
Just down the street, another project is underway. Carpenters are putting the finishing touches on an acoustical tile ceiling. Unlike painted concrete ceilings, this is a more common drop ceiling for offices.
Person in an office, they don't realize the amount of sound that gets reflected off a hard ceiling. Acoustic ceiling is nice and soft, and it absorbs the sound, and it helps to make a quiet environment. Acoustic tiles have been available as long as I've been in the business. That's like 40 years, although the products these days are much better designed and use of recyclable products for sound absorption.
Project Superintendent Rick Weiss is at the helm of this remodeling project from Leopardo Construction.
On this project in particular here, the ceiling tile we use, there's two different types. There's a mineral fiber, and then there's a fiberglass insulation. Both of them are 100% recyclable. So any waste that we have after the project is done, everything that's in it is recyclable. Obviously, the metal grid is recyclable.
Everything for this remodeling job is brand new, and special attention has been paid to use sustainable building material. The real work begins with the layout and planning of the ceiling's grid.
Even though when you think of carpenters, you think of wood, and we strictly work with metals, the carpenter's skills are still all the same skills. Plumb, level, square, this is what you're looking for when you install a ceiling. So the same tools and knowledge that you'd use as a wood carpenter is the same tools you use to install a grid ceiling.
A skilled carpenter makes the installation look easy, but for the layout process, there are no shortcuts, only experience and sweat equity.
The most important thing you do at the beginning is you have to establish the ceiling height. And so establishing a ceiling height, you have to get your sheet metal contractor, your electrical contractor all involved to make sure that you have the proper clearances to get their pieces in after you're done with the acoustic part of it. So you lay your pattern out on the floor, mostly because it's more productive to do it that way rather than try to be up on a scaffold and moving around. And then you can take it and you just plumb your marks up to the molding on the walls. After you do that, which establishes your molding around the perimeter, then you shoot all your hangers.
Shooting hangers is not tricky at all with the help of a specialized tool that shoots the hangers into place.
After your hangers are done, you take your layout, you bring it up, establish it on the ceiling, and then you start installing the grid. Main runners come first, 4-foot tees after the main runners. The carpenter, again, is responsible for putting in the acoustic tiles. And the challenge to that is, depending on how much space you have above, is getting the tiles in without getting a score on the face of them. And the other challenge would be is your cutting of borders. You have to, border is basically on your modern day tile kind of gets scribed to the border, and it can be a time-consuming process. The carpenter motto is you know, measure twice and cut once. The labor is actually the most important part of it, because what you have is, going back to your layout, your layout has to be where it belongs, and it's important to use, you know, your training as a carpenter to bring that aspect of it to it, because if you don't, if the layout in the beginning isn't correct, nothing else will follow. So you really want to do the project one time from the beginning, starting from the layout correctly, and then everything will flow together from there.
Whether your construction challenge is commercial or residential structures, we hope that our guests today have helped you build a good foundation for best practices in the construction trades. I'm Bruce Obora. Thank you for watching Built to Last.
Visit the Built to Last website to learn about these topics and more.